All right, y'all. So today we're going to spend some time talking about covalent bonds. So we have learned about ionic at this point, and that's where we had something like losing and gaining electrons. There were ions involved in ionic bonding. Covalent is going to be a little bit different, okay? And so we're going to spend some time. It's a different kind of bond, a different type of naming rules, different rules for writing formulas. So kind of put ionic out of your head for a minute and let's look at covalent. All right. So, covalent bonds, they are going to be formed by the sharing of electrons. So this is the difference. Ionic, right? Something lost electrons to form an ion, and something gained those electrons and formed that ion. That is not the case for covalent. It is the sharing of electrons, and this is typically going to occur between two nonmetals. One thing I do want to take some time to point out is that hydrogen, even though it's on the left side of the periodic table, it's in that first column. Hydrogen can act as is going to participate in covalent bonding as well, because it just has that one electron. So hydrogen is going to be our one enigma here. So we have those top right triangle of the periodic table, those nonmetals right above the staircase, and hydrogen, all right, occasionally is going to be involved in these covalent bonds, okay? And so when we look at something, here's our example using hydrogen. Hydrogen is happy with this sharing of electrons going on. And so that's what we see here. Hydrogen is an example of something that we call a diatomic. So diatomics, so di, right? So that part of the word should make you think about the word two, right? Di meaning two, and atomics, atom, right? So diatomics are two atoms, and these are going to be atoms that cannot exist alone in nature, okay? Atoms that cannot exist alone in nature. They are always going to bond to themselves. And this happens because they can fill their octet by simply bonding with themselves. And so when you have hydrogens floating around, they just whoop, go together. Fluorines floating around, you don't have just these fluorine atoms. Rather, you're going to have fluorines that are naturally going to join together. And so your diatomics, there are 7. The easiest way to memorize them is if you were to try to say them out loud as if they were a word. So these are your 7 elements, okay? Bromine, iodine, nitrogen, chlorine, hydrogen, oxygen, and fluorine. And if you try to say it as a word, that would come off as Brinkelhoff. So whenever I can give you these ridiculous ways to memorize stuff, right, I'm here to help. And so these elements, like I said, they just naturally bond to themselves as they are floating around as atoms. Whereas you can have individual lithium atoms and iron atoms and sulfur atoms. These 7 are going to bond to themselves. So let's take a look at why that happens and what it looks like. So here is fluorine. Okay, so fluorine has that lovely just empty spot right here. And this fluorine has its empty spot as well. And so those atoms can naturally fill in for each other. They just go together and boop, that empty spot just fills right in. Okay, and so fluorine is going to exist hanging around as F2. Okay, and so that's what's happening with all of the diatomics, even something like nitrogen, right? So nitrogen 1, 2, 3, 4, 5. Nitrogen 1, 2, 3, 4, 5. It just kind of shares with itself. It's going to share here, here, and here, okay? They just naturally share with each other and make those bonds, okay? Because they can fill each other's octet naturally. They don't need other elements to come in. So here's a look at just a example of a covalent bond again. So notice there's not this loss of an electron happening. It's when that sharing occurs, we get this beautiful octet right here around the carbon. So let's look at some more. So nitrogen and fluorine. So the best way to do this is start by drawing the Lewis dot for each individual element. And you guys worked on this before, so this should just be a refresher. Fluorine, 1, 2, 3, 4, 5, 6, 7. Remember, you're using valence electrons to figure out your how many dots to do. Okay, and so we can see these empty spaces for the elements where bonds need to happen. So we've got a space here, and a space here. Neither nitrogen or fluorine are going to just like give away 5 or give away 7 electrons. They're going to make space for each other. So it's easy to see right off the bat that if we have that nitrogen, we can just slide that fluorine where it has its empty spot right over. But now when we look at nitrogen, it's still not done, right? Like there's still those empty spots. But I am telling you that the elements involved are nitrogen and fluorine, okay? They're not, you can't just bring in like something that has one just to like be happy. No, okay? These are the puzzle pieces you're trying to work out. So what happens is you're gonna bring in another fluorine because fluorine always has one empty space, okay? And so it can only bond one time. So we bring in another fluorine. And then it had the rest of its octet already full. And then we bring in yet another fluorine. Okay, so this friend here is NF3, okay? And so what I'd like for you to do now is you're going to go ahead and try to solve this one on your own. So the video is going to pause, head on over to your notes, fill this one in, and then come on back. Okay, so hopefully you really did give this a big go before just pressing play. Otherwise, that's a waste of time for you. So if you need to press pause and try again, don't cheat. Okay, so sulfur had 6 valence electrons, right? We just had that in our multiple choice. And then bromine is going to have 7. Okay, so we've got like that one space here. And then we have 2 spaces there. And so we're going to go ahead and put that sulfur in the middle because it's got like more openings, right? So it's going to need more friends. So we've got sulfur there. Bromine has the one empty space where it can come in and share. And now when you look at these atoms, they all have 8 around them, which means they're all happy, right? That was the goal. So this would be SBr2, okay? So these are molecular compounds. So let's talk about how we name these things because it's not simply like sulfur bromide or nitrogen fluoride. We got to be a little bit clearer and a little more creative with our molecular compounds. The idea is still that they are going to be neutral, okay? That is still going to be the case. They are going to share electrons, still going to be neutral. One key thing to keep in mind is that this has nothing to do with ions. So the fact that fluorine has a -1 charge or nitrogen has a -3 charge does not matter, okay? Doesn't matter. Don't look at charges. Has nothing to do with these things, okay? So again, here we go. We are looking at this sharing. Let's talk about how we name them. So I'm just going to pause the video here so that you can take some time to read through this. All right, so hopefully you took the time to actually read through this, okay? Again, the idea is that you're going to identify the elements that you see. So like, do you see nitrogen and fluorine, oxygen and sulfur, bromine, iodine, whatever. So identify them. The element that is listed left in the formula, you name it first. Okay, and then the element on the right gets named second. And just like before, you are going to add that ending IDE. And then it says use the number of atoms of each element, and you're going to include a prefix. So if you think back to our ionic formulas, when we saw something like Li2O, we just ignored the 2 when we were naming it because that all had to do with charges. That's why it was Li2O. That is not the case for covalent. We are going to have to identify in the name how many there are of each element, okay? And so we are going to use some prefixes to get through this when we're naming things. So you guys have heard of carbon dioxide. You've heard of carbon monoxide. Most likely those are things you've heard of, right? And so you actually already know 2 covalent compounds. So here we go. Here's a list of prefixes. You do need to memorize these. So one more little piece of memory work before the test. And so what you will see here is I put those A's in parentheses. I should have done so for tetra as well. The A's are there to make things like sound better. There's no hard and fast rule. So if you think about saying like hex bromide versus hexa bromide, hexabromide just kind of flows a little bit better. I'm never going to be grading you on whether you use an A or not, okay? Because there isn't a rule to follow. It's just like Sounds better. Okay. So that's why those A's are in parentheses, because they're like kind of needed. So A's, use them, don't use them. You will get better with the language as you grow into your chemistry career. So let's take a look at how this works. So similar to before, the question will read, what is the name for XYZ? So here we go. What is the name for CO? And so what we do, right, the process was identify the elements first. So carbon and oxygen. And then the next step, right, it said use the number of atoms of each element present in the formula to find its prefix. Okay, so there is one carbon and there is one oxygen. And so our prefixes for one is mono. Okay, so mono for one and mono for one. But then we had this big comment that was bolded here in hot pink and in a box and all caps and in a different font color, right? Like trying to make it as obvious as possible. If there is only one of the first element, you do not use the prefix mono. So when you guys have heard of carbon monoxide, you have probably not heard anybody call it like monocarbon monoxide, because that's not right. All right. And so scientists, right, you keep learning. We are a lazy breed. We're like, okay, if there's just one of the first, let's just state the element. It's just easier. So we call that carbon monoxide. So here's another example. So again, the rules were identify the elements listed in the formula. The one on the left goes first, the one on the right goes second. You add IDE, right? Those were our first rules. So N being nitrogen and F being fluorine. Great. Then the next step was to identify how many of each element you have and use the corresponding prefix. So 1, mono, 3 fluorines, tri. Great. But we don't need mono if there's one of the first. So it becomes nitrogen trifluoride. And again, I really want to point out that this is totally different than ionic. When we had, a formula that was like AF3, right? Or sorry, AlF3, aluminum fluoride. We just called it aluminum fluoride. It was not aluminum trifluoride. This is only for covalent. This is only for 2 non-metals together. Okay, so if your formula, right, nitrogen and fluorine are both non-metals, and that is how you know it's covalent. Okay, so I'd like for you to go ahead and think through this one and submit an answer for this. Okay, so we had 3 phosphoruses, so tri-phosphorus. 6 is hexoxide. If you wrote hexoxide, that's fine, okay, either one. All right, here's another one. Go ahead and submit that one. So here we are going to use an A because it sounds better, but if you wrote pentachloride, that's okay. All right, so writing covalent compounds, again, you're going to go left to right. So whatever is listed left in the name goes first. Whatever is listed right in the name goes second. And then you use the prefix to tell you how many of each atom, okay? And so you'll literally look and you'll see something like, N2O, whatever. So we saw nitrogen first. And then we saw oxygen second, and it was oxide, right? So that's what we were doing on the back end. Now we're doing the opposite, okay? So for these, sorry, and that should have been dinitrogen, of course. For these, now you're going to know this part, okay? And so nitrogen is listed first, great. N. Oxygen is listed second, great. O. Then the di is telling me 2. N2O. Okay, that's it. That's how this works. So here we go. So carbon monoxide. So we've got carbon with no prefix is telling me 1. And then obviously mono is telling me 1. CO. So here's another example. Oxygen triiodide. So oxygen's first and iodide is second. No prefix means 1. Tri means 3. OI3. Okay. And then go ahead and submit for this one. Okay, so for this one, you've got di. Okay, well, my pen stopped working again. So di is telling you 2, pent is telling you 5. So that means we have 2 phosphoruses and 5 oxygens. And one more, go ahead and submit. So hex is telling us 6, mono is telling us 1, so S6O. All right, and that's it. Okay, so just to recap, be very careful with these covalent bonds. Do not use charges when you're looking at them. It's simply the prefixes. The prefixes will tell you how many of each atom that you use, okay? So do not look at the periodic table for charges for these. And again, that big idea I pointed out in the middle, this is only going to be the case when it's 2 non-metals together. All right, so sharing of electrons, 2 non-metals, that's it.